In this video, I'm going to talk about solving radical equations that have two radicals. For this first one, I have the square root of x plus 2 plus 1 is equal to the square root of 3 minus x. I'm going to, I want to isolate one of the radicals by itself so that I can square to undo it. Well, I already have one of the radicals by itself. I have this square root of 3 minus x by itself. So I don't need to do anything but square the right-hand side to undo that square root. If I do that on the right, I have to do that on the left. So I'm squaring the entire left-hand side. On the left, when I do that, and it will help me to make an area square off to the side here so I don't make any mistakes. I'm multiplying the square root of x plus 2 times, or plus 1 times the square root of x plus 2 plus 1. Square root of x plus 2 times the square root of x plus 2 is x plus 2. That's the square root of x plus 2 squared. Square root of x plus 2 times 1 is the square root of x plus 2. Same here, square root of x plus 2, and 1 times 1 is 1. So when I add all of this together, I have x plus 2 square roots of x plus 2 plus 1 is equal to, on the right-hand side, these two things cancel, the square root and the square. So I have 3 minus x, what's inside. From here, I'm going to simplify the left-hand side to be x plus 3 plus 2 square roots of x plus 2 is equal to 3 minus x. I know that I want to isolate now this radical, that I only have one radical left and I want to isolate it. So I'm going to take away everything on the left-hand side that is going to eventually get me to that radical by itself. So I subtract x, subtract 3, and do that on the other side as well. Subtract x, subtract 3, and I end up with 2 times the square root of x plus 2 is equal to, I have negative x minus x is negative 2x. I'm going to divide both sides by 2, and I'm going to get that negative x is equal to the square root of x plus 2. I have negative x is equal to the square root of x plus 2. Now I want to square the left-hand side to get rid of that square root. So I'm going to square the left, and I'm going to square the right. I'm going to end up with x plus 2 is equal to x squared. It's going to be positive. When I square something, it's going to be positive, so I'm just going to write it as x squared. I'm going to subtract x and 2 on both sides because I have a quadratic equation here. I need to get all my terms to one side. I have x squared minus x minus 2 is equal to 0. And then I factor to solve. So I need two numbers that multiply to negative 2 and add up to negative 1. And those numbers are negative 2 and 1. So x minus 2 times x plus 1 is equal to 0. So I know x is 2 or x is negative 3. I need to check for extraneous solutions. So I plug in 2 and see if that works. Whoops. I plug in 2 and see if that works in my equation. So I'm going to check x is equal to 2. So I have the square root of 2 plus 2 plus 1 is equal to the square root of 3 minus 2. Is this true? Well, I have the square root of 4 plus 1 is equal to the square root of 1. This is 2 plus 1 is equal to 1. And that is not true, so x is equal to 2 doesn't work. Let's try the other. So I'm going to check x is equal to negative 1. I do the square root of negative 1 plus 2 plus 1 is equal to the square root of 3 minus negative 1 or plus 1. That's the square root of 4 is equal to the square root of 1 plus 1. That's 1 plus 1 is equal to 2, and this is a true statement. So x is equal to negative 1 is the only answer for that problem. For the second example, I have the square root of 2x plus 5 is equal to the square root of x plus 7. I want to isolate one of the radicals so that I can undo it by squaring. I actually have both radicals isolated on both sides. So I'm going to, I don't have to do anything but square to undo the square root. So I'm going to square both sides. I'm going to end up with the square and the square root cancel. I'm left with what's inside. 2x plus 5 is equal to, same thing on the right-hand side. The square root and the square cancel each other out, and I'm left with x plus 7, what's inside. And And I just solve this problem. So I subtract x on both sides. I get x plus 5 is equal to 7. I subtract 5 on both sides, and I get that x is equal to 2. I'm going to check this to make sure it works. If I plug it in, I'm checking x is equal to 2. I have 2 times 2 plus 5. The square root of that is equal to the square root of 2 plus 7. Is this the same thing? Well, I have the square root of 9 is equal to the square root of 9. That's 3 is equal to 3, and this is a true statement. So x is equal to 2 is my answer.